India was, and this gentleman took a big ship and started sailing in the river and sailing in the sea, and he had enough of items for all his travel. But unfortunately, due to some reasons, there was no water to drink. So he was so thirsty, and this slogan came up: "Water, water everywhere, not a drop to drink." He didn't know what to do, and finally, all he got survived just because there was rain. He could catch the rain, he could collect it, and he can use it, and he continues travel. Let's see, if we don't take care of it, or if we don't save it, if we don't take care of it, we'll be having problems, as what he has done also. Well, water and human being have a long-lasting relationship. Man has seen his first phase in water. From there, he started living with the water. He started living near the water. You take any civilization, it all started along with water. He used to go near the water, collect it. He used to carry the water and use it how much ever he want to. And there was no much of wastage happening during those days. This water, whatever he could carry and he could utilize fully, and whenever he needed further, he used to go and collect water for further use. There was no further wastage, there was no further excess usage also. So what happens? Man, there are three things in this world, in this whole environment. If this environment has to survive, we need to have three things. That is air, light, and water. Air, we have 24 hours a day, 365 days a year. Light, we have at least 12 hours a day. Air, if it's not there somehow, we could manage to get it. If the air is not flowing, we have equipment so that we can feel the air. Light, we have methods to manufacture it. But water, nature provides water only 4 months in a year. Nature provides water for a particular period. It varies from 4 months to 6 months in different parts of our country. Nature itself tells you, my dear human being, I'm giving you 6 months or 4 months of water, enough of water for you. And it is up to you to take care of it, the balance 6 months or 8 months. When the nature is giving this instruction unknowingly, we have forgotten. The reason is that the advent of science. In the civilization, we used to stay near the water. Whatever water we required, whatever possible within the canals, channels, we used to make the water flow and we used to use it to the required manner. But as and when the science started developing, at the advent of science, what happened? Man started living away from water. Man started living kilometers away from water. And at the press of a button, at the press of a switch, he now knows that water from kilometers away can come to his doorstep, to his kitchen, or to his bathroom. So he has totally forgotten where the water is, where the water source is, and from which place the water is coming to his house. So he, with the switch of a button, without any effort, when water started flowing in the tap, in this pump, in the tubes, he started using it, he started overusing it, and he started abusing it. Friends, urbanization is a wonderful answer. Yes, we all need to live in this urban society. We need to all have our shelter. We need to have roads, we need to have playgrounds, we need to have yards, we need to have all the facilities we need. But as and when we are doing this urbanization, are we really concentrating on giving back to nature whatever we have disturbed in this nature? If you can remember, whenever we start constructing a building or a house or a whatever villa, the pujari or whoever comes for the first day prarthana, if somebody does it, the pujari, it might be in any religion, the father or mukri, whoever is, he says to the owner, we may have to cut the trees, we may have to change the profile of the ground, we may also alter the living beings culture staying in this premises. And finally, he also tells that we have to, God has to pardon us, and we would try to give back the nature whatever possible. But when the villa is built, we cut the trees, we cut the road, we cut everything, and finally we forget that water is for all, and we need to plant more trees. We forget it. We need to, whatever leveling or difference we have done, we have to somehow manage it so that it is not working on us only. Suppose we built it on floor on a slope, and whatever water is falling on our head, it's supposed to go to the nature by itself. In the earlier days, water was for everybody. Water was for all, and everybody has to have a lot of water. If at all we are not having any villas, or if we could live in the forest, imagine the water falling from the sky will go fall to the ground, and it will get absorbed into the nature slowly. The rainy season is a link between the sky and the Mother Earth. This is the period of meeting each other. It is a wonderful place where the new things get evolved, and new creatures are born. But unfortunately, man has forgotten that water is not for all, water is for himself, and what he covers the land. Water falling on his roof is left to fall on it is made to go through the pipes, and it comes to the ground level. From the ground, we have covered it with the platforms, and from the platform, it goes to the drains, and from the drain, we have sent it far away from the place where it is falling. Then we spend money, lay pipes from the aquifers, and pay money and get water to our doorstep. What an irony. So it is man's urge has started. When the water was falling from the sky, he used to catch it and hold it and use it. If he doesn't do that, if he doesn't get that water, he will start digging the ground. But that is also not possible. He has science in his hand. He started going deep into the ground. He started using it. He started overusing it. He started abusing it. How deep we can go? Is there any limit? Probably in your area, it is around 600 to 1,000 feet. And I'm also hearing that people have got 1,200 feet, 1,500 feet below in search of water. And finally, they don't get clear water. They have water mixed with all minerals, and they face a lot of problems. So over the years, be in construction or be in natural process, we have forgotten the reduce, reuse, recycling, refraining, restricting, redirecting, and all the R's will hold good as far as the water is concerned, because water is for all. The matter comes here with the sustainability. What is sustainability? How we can sustain? It's very interesting that we sustain each and everybody. In our office, if the boss is not very come close to us or not accommodating us, we somehow sustain him. In a hostel, when a new partner comes into our room, and we have to stay together, a twin sharing basis, in spite of all his animosities, we sustain. Marriages, husband and wife, they don't know each other, they sustain each other. But when it comes to the nature, we act freely. We are not talking about sustainability there. We cut trees, we grow, we demolish everything, and man becomes very greedy, and the matter of sustainability goes sideline. This is not sustainable. The state at which the components of ecosystem and their functions are maintained for the present and for the future generations. The National Building Code very clearly states that the sustainability comes when we maintain the present and the future. We have to maintain. That is sustainability. Well, sustainability, there are a lot of other things to be maintained. Because of economic activity, the world is moving. Yes, we are also moving in that. The socio-cultural identity is there, where many of our Indian tradition says that we need to go with the nature. We love nature, we praise nature, we worship nature. But as far as the usable sustainability concerned, we slowly forget to think that we are not doing right judgment there. The environment is common to all. The environment, this whole world can sustain without the human being. But we human beings cannot live, just cannot live without the environment. Well, coming to our own field construction, well, let me get into now real little bit of technical. We have 40% of energy construction uses, and we use around 42% of water in our construction, and 50% of raw materials, and we contribute to the pollution also, and of course, more than the water we use, we contribute to the pollution also. How do we restrict this? How do we control this? Let's work out. A lot of things are there come into picture now. Well, in the whole, when we think of water being economized, the total quantity of water available in this world, as you all know, that is whole, and then the whole we have lot of water component, but that is around 90% of these, but it is all saline. Out of that, 3% is potable. We all know that out of that 3%, some are in the glaciers, some are in the hills, some are deep inside the ground, some are deep inside the water, and so on forth. Only 1.2%, that is the small drop which has been shown there, is the water available for us. So, friends, drinking water comes from nature. In other words, it comes from nature. This is the schematic representation which tells you out of the total water available in this world, 96% is in the saline, in the sea, and another fresh of 2.5. Out of that 2.5%, we have glaciers, ice caps, the same thing which I have told you. And finally, it's hardly 0.25%. So that is why we need to take care of water. One more thing, we are all civil engineers. We design water systems, we design urban systems, we design transportation systems. We design civil engineers, we make the world, yes. But at the same time, we are not talking about sustainability in terms of the complete environment as far as the designing is concerned. For example, government has a target of supplying of 130 liters per person per day, and especially that is in the urban area, around 100 liters per person per day in the semi-rural area, and 80% in the rural area, because the people are scattered there. And how much water we use, how much water we need for our day-to-day activities. Let's come to construction later. So this graph shows you that we take a lot of water for shower and toilet. And of course, there are a little bit of leakage in faucets, and shower and toilet takes maximum amount of water. Just for hygiene, do we need to use that much of water, or there are any other methods? Well, each person actually uses around 250 to 350 liters of water per day. Apart from government supplying 130 liters per person per day, we also buy water from tankers, we buy bottles, we buy containers of water, we buy barrels of water. And on average, it is around 250 liters waters per day. There is a real study done in Mumbai which says there is around, we have per capita supply in Mumbai is around 268 liters per day. The real study has been done there. Well, what are the think tank people say? They say Rajendra Singh is the Magsaysay Award winner, the Waterman of India. He says 20 cities are going to be dried in another 2025. Chennai, Bangalore, and many cities are there in that. And is it not a man-made disaster? Are we ready to overcome all these things? Well, in water scenario, India is growing. There's a small thing which you have to note down is the irrigation used to take the maximum amount of water. But over the years, what happens is, though there's a little bit of more water to be used in irrigation, but it is reduced, because the water used for others, energy and drinking water is taking the larger chunk. And the water used for irrigation is being suppressed. Are we doing this? Are we doing the right method? The study says from the 2002 to there are 26% of India was in drought. And 2004, it increased to 34%. 2009, it increased to 52%. And if we don't take care, 50% of the whole country is facing a drought. Half of India. Are we engineers planning in the right manner? Well, let's come to construction. Water used per unit area of construction largely remains undocumented. Many institutions, we have engineers, we have students working on nature. There is eco clubs, and many institutions have students working on the nature. But this study in the field of construction is not done, hardly any documented. But study done by one university has found in 2016 that we need 27 kiloliters of water per square meter of total built-up area. So in any building, when you want to construct, you need to know whether that much of water is available in your city. But actual construction is taken. The study done by the same university says that it's around 32 kiloliters per square meter of the total built-up area. That is again 5 kiloliters more per square meter. Well, water efficiency at the production stage and in the consumption stage. That is, when it comes to construction, we need to think about construction products which have been manufactured and the construction water used during the construction stage. Well, this is research done in Australia. They say this is more than enough. Well, what does India says? It's very interesting. See, we engineers need to design a building. Now, all over India, there is a way for green construction. We have a movement which says that we need to work on more green buildings. There is a lot of agencies who give you the accreditation facilities, the guidance facility. There are green building consultants. But what does the Green Building Council say? Green Building Council says very, very clearly that out of the whole concept, 23% of the points out of them is given to water conservation. So imagine the green building also can happen a green building when there is a large amount of water saving in the construction. It may be in the usage, it may be in the day-to-day aspects, it may be temperature control, all subject, because temperature control comes very next. Sustainable design and energy efficiency, these two are the major points which control the usage of water also. Apart from that, we have material usage, resident well-being, and innovative design. So you can other also says what are the subsections which guide you in proper water utilization or water savings to be done while designing a green building or a sustainable building. So energy saving could range of 20 to 30%. Water saving can be another 30 to 50%. That is a too big percentage. 50% of the normal water usage what we are doing. Suppose we have, as the study says, if we are using 250 liters per person per day, if you can reduce it 125 liters per person per day, that will be amazing. That will be amazing. But how that is possible? See, apart from doing rainwater harvesting, I'll come to what is rainwater harvesting. And then efficient plumbing fixtures, because they are the main, because they are the water carriers. Apart from plumbing fixtures, the landscape design plays a very important role. Irrigation system, the recycling the use. Nowadays, recycling of water is taking a big leap in the construction. We have a lot of units coming up. We have total water recycling methods, even in the wastewater, like might be gray water, black water. Let's discuss a little bit of later. Then rainwater harvesting, water metering. This is again interesting. What is water metering? Water budgeting. Let's a little bit of that. We'll discuss that one by one. I'm only giving you a salient points because it is a very, very vast subject. I'll be only giving you the key points, and you can ponder on it and work on it a little bit later or during your course of study. Well, the first and foremost in the design of a sustainable construction is the design has to be a 360-degree angle. The design has to be with avoiding eco-sensitive areas. We should always, this is a common sentence that we say, we should not use forests, we should not cut trees, lakes and canals should not be disturbed. It's very easy to make a statement, but it's very difficult to follow as and when a sustainable design has to be designed by an engineer, and when he's being paid to design, and the owner says, I'm paying you for my own building, so you design it for me and just do it. But it is our duty to convince and tell the owner that this is how it has to be done. Otherwise, he will face problems. Because any greenery, any greenery you take, the amount of water you put into that, only 2% is used to prepare food. And rest of the 98% is used to maintain the ambient temperature around the tree. That is why when we go near the tree, we feel comfortable. When we go below the tree, we feel very happy. Well, rest, I will leave it to you to think and ponder on it. Then, in masonry construction, what all things we can do? Right from designing and the foundation, and next comes masonry. So, 1 square meter of wall construction and an average of 350 liters of water get consumed. And to avoid that also, to reduce that also, now we have a lot of product coming up. We have something called as what do you have called as the interlocking blocks. Earlier masonry means we were just thinking of masonry with cement mortar only, but it is no longer mortar is required to do any masonry. We have interlocking blocks without cement. We can construct masonry walls. This is one building I have done in Mangalore also with interlocking blocks. I have done many buildings. I'm showing one here where absolutely no cement mortar has been used to construct this building. But we have only cement slurry. Because of that interlocking system, I could complete this building. Only for laterite I have used because of the supporting structure as pillar. Now we have a lot of additives coming up. Adhesives are there, which consumes less water also. Then we have, I was talking of admixtures. We can reduce water consumption with reduce water requirement, maintain optimum level of workability in spite of using less water. And now people are aware that water cement ratio has to be properly maintained. Otherwise, you will tempted to lose the durability of the concrete, and then make people making aware even from the lower mason level to the owner's level. Owners think that using excessive water also will help him to get a good building, clean building. It is our duty to convince him and make him clear that use of efficient water can give him a very sustainable and strong, durable building. Now, and then, as I was telling you about this, instead of cement mortar, now we can use additives, admixtures. So there are. This is the same building. Now the designing also takes a lot of main key role. And this building, the same building which I was talking earlier in the previous slide, there's the interior of that. Absolutely no cross walls except for the bedrooms, and the ceiling height was very comfortable. And even with the temperature of 42 degrees in Mangalore, that lady is very, very happy. Like that, we have done similar buildings out here also. Then there are other technologies like, brick walled. There's a wonderful roofing element where one layer of brick without any cement screed on the top, and no cement screed or any cement layer on the top, and absolutely less quantity of cement mortar, but you get a wonderful roof also. If the proper ventilation and open space, of course, it comes in the designing. Reduce wall length, I already told you. Space efficient, making the space very efficient to use so that the inhabitants will not move around too much and exert themselves to get his job done. That happens in the design of urban design. We have called as transit-oriented development, TOD, now coming up, where the cities has to be designed in such a way that there is not too much of vehicle movement, not too much of transportation, not too much of human movement also. It should be all locally available. Transport-oriented development, it's the same thing is used within the house also. Locally available materials just to avoid further transportation and further excessive materials to be used, and which might not act so in coexistence with the nature. And vernacular architecture. If you go to olden days, we have done our buildings with total recyclable materials. 100% we could recycle. But after the advent of science, cement, mortar, and we started getting wastages so much, that is around 20% of wastage. When we are not able to recycle the materials, we are not able to use the recyclable materials. Of course, now the science has also giving you guidance how to use the recyclable material also, and government also has used a lot of government also has given a lot of guidelines to use recyclable materials in the bed or non-load bearing structures, load bearing structures. All those guidelines are also there. So we have different techniques in green building techniques, like arch foundation. We use foundation for the arch, right from the foundation to the wall to the roof. And we don't use beams whenever we use an arch foundation. No plinth beams are used. It's only between the masonry to masonry, and then the masonry is built and the earth filling is done. Then the superstructure is constructed. When we do an arch, we avoid lintel. Totally lintels are avoided. You can see in this building, and we also use mud block, rammed earth. Of course, it is not common to everybody, but if you try to use this as I've used in that building, and you can save a lot of materials because the temperature is totally controlled when it is within the house. Exposed masonry is one thing. Whenever you expose a masonry, you use less cement. That is, a heat intensive material is avoided, and you're allowing the wall, the masonry structure to breathe. When you allow the major masonry structure to breathe, naturally it will give away the heat very fast, and you will feel more comfortable in the evening, and it will not get heated up whenever during the summer also. Exposed masonry are a wonderful concept, which earlier days we were using very, very rampantly, but with the advent of many what is stucco plastering and other fine materials, and because we wanted to look our building very, very posh, we are forced to plaster and give another layer of coating and another layer of finishing, and which will add to the heat of the building, people staying inside. So filler slab is one technique. This is a filler slab used here, and where RCC is hardly 50% of the cement is used. And with this filler material, the filler material is designed as per IS 456 2000 only. And only thing is, the concept of filler slab is interesting. The reinforcement below the neutral axis, the concrete below the neutral axis is dormant in design. So the concrete does not take part in the design below the neutral axis because it is in tension. So remove that portion of the concrete and insert a lighter material or a hollow material. So what happens, though, when you use a lighter material or a hollow material, especially when it's a clay product, then it will not get heated up. The weight of the total weight of the slab also will come down, and at the same time, you will have less reinforcement and you will have a comfortable feeling inside. The brick wall roof is also same thing. It is done here. We also can see it here. Then there are other methods also, and already talked about this. We can avoid heat-intensive materials, and oh, sorry, that's repeated. Now coming to harvesting water. Now water in construction. What people think rainwater harvesting means harvesting water when there is only rain. Rainwater harvesting is not done only during rain. I'm sorry, because rainwater harvesting is a concept which we have taken from the age-old principle of harvesting the paddy. The paddy, when it is grown in the rainy season, or when we have enough of water, the paddy is grown, and when the plants are grown, we remove the grains and remove the hay, and we collect the rice, paddy grains, and we store it. And when there is no rain, we use the same grains and use it as rice. And will not drop even one seed of rice, we will not drop it because so carefully we use it for our day-to-day life. And in other words, the whatever paddy we have grown during rainy season, we use it in the summer till the next rain comes in. So it's understood that rainwater harvesting is also a 365 days activity. You hold the water, you store the water. It might be in your own sump, it might be in your own well or in your bore well, or it might be in your own ground. As I was telling earlier, that is when the rain comes, water used to fall on the ground and new plants used to grow. We have covered it. We have covered it with interlocking. This is my own office. We have covered it with interlocking. And we have covered our house with the roof and the water falling on the roof. Is at least take it with the pipes, take it down with the pipe, add a filter in between, and try to store it in your own tank or in your own open well. This is my own house, and this is our own factory. This is or put it to your own ground or into the borewell. The deep aquifer, that's a different concept. I'll come to that later. And the importance why I'm telling you this is water is free. You don't have to invest again and again. It's a very simple common sense. You don't have to have any rocket science in this. It's a pure common sense. Whenever you all want to have water, when it's raining, you open your mouth, you can drink water because rainwater is the purest form. Except the pre-monsoon, which is the first few rains. Then the first few rains are there to only to wet the ground so that make the temperature comfortable. Then when the heavy rain starts in, collect it and store it, and you can use it for the entire 365 days. The whole world, the whole of our country, if you can go, different average rainfall in our country is around 1,200 millimeters per year, per square meter. So 1,200 millimeters on average is quite a big quantity of water. And if I can tell you, if we can, I was also talking about if you cannot store, you don't have a well in your house, you don't have an open well, you don't have a bore well, you don't have a sump tank also in your house. At least make some percolation pits, recharge wells, and you try to store. So you allow the water to go into the ground. At least the people nearby you and everybody will be getting water, because the water is a treasure in your own land, in your own earth. Mother Earth has got a lot of treasure. Out of that, major and important pleasure and the treasure is water. All the wealth, whatever you get it, is of no use if you don't have water. That is why water is free. And recently, government is also taking a lot of steps in Jal Shakti. They have formed a ministry called as Jal Shakti, where they're analyzing the water resources. Now they are working on it to preserve water resources. A lot of projects are coming in to save water, save the canals, save the water nearby in your areas. A lot of things are coming in. Coming to constructions, we can do a lot of things to save water, especially in our schools and colleges. We have to use if not automatic, there is water sensitive faucets. Whenever we should not put a tap which is free flowing. You should be just push button taps at least, so that the students or public, especially in Samaj Mandir and community halls, this is a must, because otherwise people are tempted to keep the tap open, so that everybody, if there are 100 people waiting in a queue to wash their hands, unless the first and 100th person finishes his washing his hand, the tap water will be flowing, and the rest of the water, whatever not used, will be going into the drain. Absolutely no use. So now we have sensor-based faucets. It might be a little bit costly, but it's worth it. We have waterless urinals. We have water-saving closets. With just 6 liters of water, we can flush our toilet commodes. in the construction now, people are adopting dual pipeline system. What is dual pipeline system? It is the recycling of grey water. Whenever a human uses water, he produces two types of water. That is grey water and black water. Whatever we are using in as grey water is all the water coming out from our wash basins and from our bathrooms and many times from a little bit of kitchen. But whatever we use only in toilets becomes a black, all of the sewage becomes black water. Both can be recycled very efficiently. And in the multi-story buildings, we have what is called as dual pumping system. Dual pipeline system is where the grey water is separated totally and it is pumped to the overhead water tank, and from there it is coming to the only to the flush tanks and only for your flushing of your faucets and closets. And when it is flushed again, it is going to as a black water. So grey water is recycled into black water, and black water can be recycled completely now. Recycled completely using what is called as a STPs and bio toilet system. The biodigester, which is a wonderful system, I'll come back to you later. And one more important thing we have noticed of late is that many of the taps are not fitted with aerators. Of course, now most of the taps comes with an aerator, but these aerators are efficient up to 20%, 20-25%. We should ask for an aerator which can give you bubbles in your water. So it comes as a spray. The water efficient is up to 80%. Only 20% of the water you are using. So these aerators are now available in the market. If your water taps are free-flowing water like this is not advisable with the handle. Now push-button taps are advisable. And these taps can be fitted with these aerators. These aerators will control the water very, very efficiently. And this can be fitted to all the existing taps, especially in schools, colleges, Samaj Mandirs, and community halls, malls, etc. Coming to curing, people always ask me, we use a lot of water in curing, water is being wasted. Now the technology has come in. There are systems where these type of covers are involved, and water is sprayed inside. And when the water is let inside, it will remain, the whole temperature remains very cool. And whenever it contains water, it will drip water drop by drop. Of course, drip curing method is one, and this is one more efficient method which has been designed by a startup company, and which is now getting popular. And we can say 50% of water used for our curing purpose. And we use a lot of water for our staff and our laborers to waste water for their hygiene purpose. Of course, you need not waste. At least provide a percolation pit and allow the water to go into the Mother Earth. Mother Earth is a wonderful purifier which no human being can design. This water, the grey water, whatever goes into the ground, gets purified, and if you're well nearby, you can make out the water table will rise up without any difficulty. So surface runoff can be avoided. So whenever there's a lot of water, especially in the cities, we talk about urban flooding. Instead of urban flooding, why there is urban flooding? Because the multi-storied buildings, the flats, the schools, colleges, malls, cinema halls allow all the surface which has been covered with their interlocking or concreting surface, allow the water go into the road, into the main driveway. Instead of that, make a percolation pit like this. Allow the water to go into the ground. This is a simple example, very, very simple example. I'm showing you. There's a small percolation pit. The water is not overflowing. The water is not overflowing. Continuous water is being flowed and the water is being absorbed by Mother Nature. This can be done. Instead of letting your water going into the roads, we can sustain the water. So we have done a big building where this is a commercial tax office building where we are almost saving 25 lakhs liters of water. We have put into the borewell. Another 25 lakhs of liters of water is taken into the percolation pit there. When we have more water, let us build a deeper percolation pit or a little bit of wider pit or a recharge well. When we want water, we can go hundreds and thousands of meters below the ground, at least to give back to nature. We can do at least 20 feet deep recharge well so that we can give back water to the nature. So, well, again, I think this is a repeated slide. Return what you draw from the ground because water is free. And this is the method of how you do recharge to your bore wells. It is very, very simple, and lakhs of liter can be given back to the deep aquifer directly. And in a running bore well condition also, there will be no difference in quality of water. And especially when you have a construction, you have a natural ground there, try to use water with a natural harvesting ponds. These harvesting points will help you to get lots and lots of water, at least 50% of the water, what we are, instead of drawing from the deep bore wells, you can use it from these water collected, which has been given by the nature. And finally, I'll come to the water budgeting. It is very interesting. We get water from municipal corporation and we pay. We know how much water though it's subsidized, we pay, and we are very happy to pay because it's subsidized. Only one country in the whole world which is charging whatever it has been spent on providing pure drinking water to the human being, to its citizens, is Israel. That's why Israel is water efficient country. I mean, they have not only efficient, they are abundant. That point I'll come to later. So if at all you have an open well or a bore well, have we, any one of us, have put a water meter and we have calculated what are the water we are drawing from our open well, or how much water we are drawing from our bore well? None of them. There is a very simple calculation. Whatever you use from the corporation and whatever you draw the water and whatever you buy, just keep a calculation and divide it by number of people using that water in your house. You will come to a conclusion that you will know the exact amount of water you be using in your own houses. Well, there are people who practice this also. I'm not telling from a hypothetical situation. The village like Kolegaon in Maharashtra is a wonderful example. They calculate water falling on their surface. They calculate water, how much is the rainfall that year, and they install water flow meters and they supply water for all that they have got called as water passbook. And the village maintains a water passbook for each and every person, how much water has been given. And they also plan Panika passbook. And they also plan what are the basis on the water condition available, the quantity of water available. They also plan what are the types of grains they have to grow in this particular year, so that the water is efficiently used. There are other concepts like in one Hyderabad, there is a small community where people join together and 3-4 farmers join together and use one bore well, and they collect water and spread from all of it. Instead of everybody taking a bore well, drilling a bore well, it's like, pricking your own body with so much of injections and you're not able to sustain. The mother earth is also the same thing. The bore well is like an injection drawing blood from Mother Earth. So this is a wonderful example, and there are other examples in the country also. And this is one of the biodigester where you completely recycle the grey water. Grey water, the biodigester is a wonderful technology. Now it is very clearly publicly used. It was only used by DRDO, Defense Research Development Organization, and nowadays Defense Research Development Organization, after using it for their own army men, now they have given it to the railways. Now we can see all the railways toilets are being with biodigesters where the water is totally recycled. The railways tracks are clean. People are very happy. Same way, you can also recycle 100% of your garbage water or the sewage water, where this has a very simple technique of only 3 compartments, and they give a certified suppliers from the DRDO. They give what is called as a bacteria, and they have a specific calculations for particular number of people. I have in my office, I'm using it for the past 2 years. We have a biodigester. This is installed in my office with 50 people capacity. My staff strength is 25 day-to-day users. But whenever there is a meeting getting on, there are around 50 to 60 people coming in. So an average 50 people, you hardly need around 4 feet by 4 feet by 4 feet depth tank, waterproof tank, so that not a drop of sewages goes into the ground or contaminates your nearby water source. And within 12 hours, 24 hours, the water is totally recycled, the gray matter is totally recycled, and the clear water comes out. And this clear water can be used for your, it is not potable, it can be used for your gardening purpose. So this is very eco-friendly material and low space requirement and 100% recycling of water. Finally, for your kind information, another 5 minutes. I think my time is running up. I have a water channel called as YouTube. In Water is Life, you can type and you can get a lot of information on what is rainwater harvesting, how to do rainwater harvesting, what are percolation pits, how can we use percolation pits. I have not gone there technical as far as the construction is concerned because it's for the common man. And I always say we have to use water like money. Because when is there a cash-rich company, when there is a cash-rich country, there we have a lot of things flourishing. We can become a cash-rich company when we have a lot of water surfaces in our whole, in our own city. We should not encroach water surfaces. We should not contaminate water surfaces. All these things you know. That is pure cash. But what is SB account? SB account is your own open well or your own bore well where you can take a little bit of water and you have to recharge it. It's like in a mobile. Unless you recharge it, you will not get water. But FD is what fixed deposit that whenever you are in difficulty, only you need to tap FD. Whenever you're in difficulty, you want to have a big function, or when you're in deep trouble, then only you encash fixed deposit. That is deep aquifer. Water needs around hundreds of years to go deep into the ground. So, on an average, in a year, it is said that water travels only, in a given rainy season, it travels only 100 to 150 feet on an average, depending on the soil condition. So you trap that water, you can collect that, use water, so that next year, again when the rain comes, it gets refilled, so that there is no imbalance created. But using borewell during rainy season is foolishness because you are withdrawing water from your FD account, and finally, when you're in trouble, there'll be no water left out. So recharging is must. This is about Israel. I'm not talking about this Israel. This video is there. So my time is up. Whenever you want to save water, be it in construction or be it in your day-to-day life, if you bother about it, what people will say, then the movement cannot be taken forward. Whatever might be, it is the nature's treasure what we are getting in. It is the nature of what has helped us. It is our duty to save and conserve water. So thank you very much. I'll be very happy if there is any questions.
Thank you very much, sir. Very informative and practical sessions. With the short time period, you covered a lot of things, and definitely some of the points the participant will definitely carry with them and do analysis for it. However, there are two quick questions. One question is that the buildings which you have shown, right? These buildings are really good, but the Ayushi wants to know that these structures require regular maintenance of any kind. Are there any limitations of the construction with arc beams, mud blocks, and pillar slabs?
No, sir. All these mud blocks, filler slab, I've been using for the past 28 years. Since I've undergone a training in the year 1991, and I started doing construction in filler slab, mud block, exposed masonry. It is Mangalore is getting an average rainfall of 4,000 millimeters. So heavy rainfall, it's so heavy rain, and there's a lot of wind and all. In spite of all those things, people now do it themselves, because it was just initial days I had to face opposition from the clients. But now I am quite busy, occupied in promoting the technology. We don't have any issues as far as the filler slab is concerned. We don't have any issue um, on as far as the exposed masonry, mud block, and these technologies are concerned. We are absolutely fine. All my buildings are made of these technologies only. If you go to my website and my Facebook also, you'll have a lot of photographs of all these things.
There is one more question, that what is the size of percolation pond, percolation pit?
Yeah.
Approximate size of percolation pit.
See, whenever you do a building for a big building, and the percolation pit designing depends on the type of the soil and the amount of water you pump in. If the soil is very rocky and it does not absorb water that easily, the percolation well, recharge well might get filled up and it might overflow. So then you may have to go deeper. What video I have shown there, where 25 lakhs liters of water annually comes in, that is annual. But on a given rainy season or a given rainy day, the water might come, say, to the extent of maximum 1 lakh liter. If the water can be absorbed very easily, then percolation pit can be to the extent of 10 feet only. Normally, on an average, for a house, I only suggest for around 1 meter dia, around 1.5 meter to 2.5 meter deep will suffice. If it is a multi-storied building, say 1.5 meter to 2 meters dia, say 3 to 4 meter deep will suffice on an average. There's a thumb rule.
There is one more question, that the filler material, will it be used filler slab? Can it be used for multi-storied building also?
Yes, it can be used for multi-story building also. I have done multi-story buildings. I can give a separate lecture on that separately. But now we don't have time. I have done multi-story buildings. Pillar slab itself, no problem.
Rakesh, I think you have raised your hand. You can unmute and ask question. Rakesh. Shall I read your question, Rakesh?
One question is there, whether biodigester is for grey water or black water. It is for black water only. Biodigester is for black water only. Difference between alternatives, plastering materials, especially in the grill bedding. There are different plastering materials, we can start from mud plastering. From mud plastering, you can have not only mud fiber can be put so that, you can avoid cracks. Then we have a lot of, then of course, cement, we have fly ash, gray, slag cement and all can be used. Any other question, sir?
Or alternative plastering material used in specifically green building. That is, Saurabh is either informing or saying. Alternative plastering material.
Sir, what are the different alternative materials other than cement? Just you have said that mud plastering.
Yeah.
That's right.
One is mud, sir. Other one is that's what. Other one is very simple. That's what, cement mixed with mud and so on. Even with the mud also, we mix 5 to 7% of cement and 3 to 4% of lime. So that mud, is vulnerable for termite attack. So we should not get into termite problems. So we do that also. Apart from
shall
mud,
we use a gypsum plaster?
Pardon me, sir?
Shall we use a gypsum plaster, gypsum mortar plaster for the plastering purpose? Gypsum plaster board?
I have not used gypsum.
Yeah.
I've used what is locally available materials only. It can be done, I think. So you can work on it, sir.
Okay.
Nice
Okay,
question.
sure, sir.
Thank
you so much, sir. Thank you so much.
So thank you very much, sir, for lecture which has covered the practical aspects, including that of the rainwater harvesting. and all you can see from the response of participants that they all have enjoyed it very much. So thank you very much for your sparing your valuable time. Thank you, sir.
I have given my email ID, and it might be regarding water or it might be regarding my construction also, alternative materials. You can ask me questions, and you can post me questions also. I'll be very pleased to answer. You can also call me or text me on my mobile. I'll give my mobile number.
Yes, sir.
So whenever I find, I'll browse that or I'll go through that and give you the needful whatever reply, whatever best possible answer I can give you with little bit of my
Thank you,
knowledge.
sir. Thank you, sir. Thank you, sir. Thank you so much. Thank you so much.
Thank you, sir.
I can leave, no?
Sir. Yes, sir.
Thank.
Sir, participants, we are waiting for Dr. Gopal Krishnan to join. I don't know whether he has joined because I don't see his name here. Sir, have you joined? So we'll have a break of 5 minutes. Let me check out whether Professor is about to join or not.